Hello everyone. So today's topic is trigonometric functions. So we have studied the uh, trigonometric identities, and application of trigonometric ratios. In solving the problems related to heights and distances. Here we will generalize the concept of trigonometric ratio, to trigonometric functions. So our first topic is angles. So angle is a measure of angle is a measure of a given ray about its initial point. We have this point, and this is a ray. So if we rotate in anti-clockwise direction with an angle theta, then theta is angle. This is called ray, and this is called fixed point. We can also rotate clockwise. So so this is a ray, and if we rotate clockwise by angle theta, so angle theta is the angle, and this is a ray, and this is a fixed point. So next we have how to measure angle. How to measure angle. How to So there are three parameters: initial side, terminal side, and the vertex. So these are three parameters to measure the angle. So we have first is we have a ray, and this is a initial side. This is initial side which is fixed, and this is called vertex. So based on the terminal side, we have two types of angle: positive angle and negative angle. We have positive angle and negative angle based on the position of terminal side. So if the angle is anti-clockwise, if angle is or we can say rotation is anti-clockwise. That means this is a vertex, this is the initial side, and if we rotate this initial side anti-clockwise, we get a terminal side. So this is a terminal side, which is obtained by rotating initial side anti-clockwise by an angle theta. And this is the vertex. So this is a positive angle. This is a positive angle. Now we have a negative angle if angle or rotation is clockwise. So we have vertex, initial side, I initial side, and we have to rotate clockwise to get the terminal side. So here theta will be negative. This is terminal side, and this is vertex. So this was about how to measure an angle, whether positive angle or negative angle. Next we have what is a measure of an angle. What is a measure of an angle? So the measure of angle is the amount of rotation performed to get the terminal side from initial side. Is the amount of rotation performed to get initial side. So theta is the measure of angle. Theta is a measure of angle. So this is, we call it theta. It can be positive, it can be negative, based on the position of terminal side, negative and positive. Next we have degree measure. So we have two types of measurement of angle. First is degree measure and second is radian. So theta has two units. It can be measured in two units, degree and radian. So we have degree and radian. So first is degree measure. If a rotation from the initial side to terminal side is 1 by 3/60th of a revolution, then angle is 1 degree. An angle is 1 degree. Or we can say in mathematical notation 1 degree. So we have some diagrams to show how to measure angle in degree. So first we have 360 degree. This is initial side. This is vertex. So if we rotate it 360 anti-clockwise, we get the same position. This arrow indicates the rotation of terminal side. Rotation of terminal side. So it is initially side and terminal side both. 360. So this measure we write it as 360. Second is 180 degree. So this is anti-clockwise. This is also anti-clockwise. This is ray. This is initial side. This is vertex. This is initial side. And if we rotate it anti-clockwise 180, so this is like this. So this is terminal side. Third is 270 degree. 270 degree anti-clockwise. So this is initial side I, and this is vertex. So if we rotate it anti-clockwise, we get 270 degree like this. This is a terminal side. So 270 degree. And if we have 90 degree anti-clockwise, so this is initial side. This is vertex, and if we rotate it anti-clockwise, this is 90 degree. This is terminal side. Now last we have clockwise rotation. 30 degree clockwise rotation. So this is initial side. This is vertex. So terminal side will be clockwise. So angle will be negative 30. This is vertex. So we can draw for other angles also, whether anti-clockwise or clockwise. Next we have relation between time and angle. Relation between time and angle. So what is the relation between time and angle? So 1 degree is equal to 60 minutes, or in symbolic terms we can write 60 dash, and 1 minute, we know 1 minute have 60 seconds. So we can write in symbolic form 1 dash and 60 second means double dash. So minutes means single dash, and seconds means double dash. So 1 minute is equal to 60 seconds. Next we have radian measure. This is the second type of angle measurement, radian measure. So first we have first make a unit circle. Make a unit circle. So unit circle means circle with radius with radius r equal to 1 unit. So this is a circle with center O and its radius is 1 unit. Now second we have subtend an angle by an arc length 1 unit. Subtend an angle by the arc length 1 unit. Arc length 1 unit. So this is a circle of 1 unit radii with center O, and if we subtend an angle theta anticlockwise, so this length is 1 unit. This is called arc length. So this angle is called 1 radian. So this is a definition of radian. From the above construction, we can define radian as follows. So radian is angle subtended at the center by an arc of length 1 unit in a unit circle is said to have measure of 1 radian. So this is a definition of radian. So this is a definition of radian. So likewise, if we change the arc length, we get the different angle measurement. So if we change the arc length, we get different angle measurement. So in general, if arc length is L is equal to L and radius is equal to R, then theta is equal to L by R. So this is a basic formula. Theta is equal to R, where theta is in radians. So next topic is what is the angle of one complete revolution? What is the angle of one complete revolution? So we know circumference of a circle is 2 pi r. Circumference of a circle is equal to 2 pi r, and if radius is 1, if radius is equal to 1, then circumference is 2 pi. C is 2 pi. So we can call circumference as C. So C is 2 pi. So we can also say circumference is equal to arc length. This is arc length. So we have arc length C equal to arc length or equal to 2 pi, and radius is 1. Radius is 1. Therefore, angle subtended by a arc radius is equal to 2 pi. 2 pi upon 1. So 2 pi radians. So this is the angle of one complete revolution of a unit circle. Theta is equal to 2 pi radians, which is the angle of one complete revolution. Angle of one complete revolution. Next is what is the relation between real number and radian? What is a relation between real number and radian? So whenever we have the angle in the form of real number, then the same number is taken as a measure of angle in radians. Whenever we have angle in the form of real number, then the same number is taken as an measure of angle in radians. So for example, 2 is a real number, 2 is a real number, therefore theta is 2 radians, which is not equal to 2 degree, because degree and radian are two different measure of angles. Radians, two different angle of measure. Or we can say, or we can take 1 as a real number. 1 is a real number. Therefore, theta is equal to 1 radian, which is not equal to 1 degree. Similarly, for many other real numbers, we can directly write them as angle of measurement in radians. Hence, radian measure and real numbers can be considered as one and the same. Can be considered as one and the same. Next way, what is the relation between degree and measure? Degree and radian. So what is the relation between degree and radian? So we know one complete revolution is 2 pi radians. One complete revolution is equal to 2 pi radians. And if we write it in degree, then one complete revolution is equal to 360 degree. So from this we can write 2 pi radians is equal to 360 degree. So 1 radian is 180 by pi degree. So this is very important. Or we can say 1 degree is pi by 180 radians. For example, we have 30 degree, which is equal to we know 1 degree is equal to pi by 180 radians. So 30 degree will be pi by 180 into 30, which is equal to pi by 6 radians. So 30 degree is equal to pi by 6 radians. We have another example. Uh, Convert this measure in radians. So first we have to split this into two parts. This is 40 degree and this is 20 minutes. So for this we can write, we know 1 degree is pi by 180 radians. So 40 degree will be pi by 180 into 40 is equal to 2 pi 2 pi by 9 radians. So this is for 40 degree and we have 20 minutes. So we know 1 degree is 60 minutes or 60 this. So we can say 1 minute is equal to 1 by 60 degree. So 20 minutes will be 1 by 3 degree. So we also know 1 degree is pi by 180 radians. So from here we have 1 by 3 degree is equal to pi by 180 into 1 by 3. So pi by 540 radians. Now we add this two measurement. So 2 pi by 9 radians plus pi by 540. So we get multiply this by multiply multiply this factor by 660 and numerator by 60. So we get 120 pi by 540 and here pi by 540. So it is equal to 121 pi by 540. So we have 40 degree 20 minutes is equal to 121 pi by 540 radians. Next we have another example. So if the so we have if the arc of the same length in two circles subtends angles 65 degree and 110 degree at the center, then find the ratio of their radii. So we have two circles, first and second. So according to question, we have arc length is L and both arc lengths are same. We have theta 1 is 65 degree and here theta 2 is 110 degree and we know relation theta is equal to L by R. So from here, from this relation we can compute theta 1 is equal to L1 by R1 and theta 2 is equal to L2 by R2. So we know L1 is equal to L2 is equal to L. So we can say L1 is equal to L2. So L1 is equal to theta 1 into R1 and L2 is theta 2 into R2. So we can separate the terms on either side. So theta terms on one side and theta radius terms on one side. So theta 2 on theta 1 is equal to R1 upon R2. So R1 upon R2, we know theta 2 is 110 degree and this is 65 degree. So we don't have to convert this because it will ultimately cancel out if we convert this in radians. So pi by 180, so it would cancel out. So 5 by 13, 5 into 13, 522. So our ratio of radius is 22 by 13. Uh, so next we have trigonometric functions. So, so in previous classes we know about the trigonometric ratio for the right angle triangle. So this is a right angle triangle. ABC, where BC is this is base, this is perpendicular, and this is hypotenuse. So we know this angle C is theta. So from trigonometric ratio, we know sine theta is perpendicular upon hypotenuse, and cos theta is equal to base upon hypotenuse, and tan theta is equal to perpendicular upon base. And we know cosec theta is inverse of sine theta, and sec theta is 1 by cos theta, and cot theta is equal to 1 by tan theta. We also know cos square theta plus sine square theta is equal to 1, and 1 plus tan square theta is equal to sec square theta. So there are many other trigonometric identities. So these are the important ones. So now we will define the trigonometric function in terms of radian measure. Trigonometric function in terms of radian measure. So trigonometric functions will help us know the different angles at which we get the same value of trigonometric ratio. So trigonometric functions will help us know the different angles at which we get same value of trigonometric ratio. So now consider a unit circle of radius r is equal to 1. So we draw a unit circle so so this is a Cartesian coordinates. This is y-axis and this is x-axis. So we draw a circle. So this is a circle of radius 1. So this have a radius 1. Now second point is mark points A, B and C, D. Mark points A, B, C and D. So if we have this Cartesian product, so, so this is, so now we draw a circle. So if we mark points A, B, C and D. So this is point A, and this is point B, and this is point C, and this is point D. And this is a center O. Since we know radius is is equal to 1. So this length is 1 unit, and this length is 1 unit, and this length is 1 unit, and this length is 1 unit. So we can say so we can say point because this is real axis x-axis and this is y-axis. So we can say point A is 1 comma 0 and point B is 0 comma 1 and point C is minus 1 comma 0 and point D is 0 comma minus 1. Now take any point on a circle P. Now take any point on circle, let's say P, whose coordinates are x comma y. So this is a Cartesian coordinate, and this is a circle of radius 1 unit, and these are points A, and this is point B, and this is point C, and this is point D. So if we plot, suppose this point is P, x comma y. So we get this. We get this point by rotating initial side, where OA is initial side. Initial side. If we rotate initial side by angle theta anti-clockwise, so this is so if we rotate this OA initial side by angle theta anti-clockwise, we get point x comma y. Now construct a right angle triangle with point P as the vertex. So this is a right angle triangle. Let this point be M. And we know the coordinates of A, B, C, and D, 1, 0, and 0, 1, and minus 1, comma 0, and 0, comma minus 1. So from triangle POM, from triangle POM, where PM is equal to Y, where this PM is Y, and this OM is equal to X. OM is X, and PO is 1 unit. Is 1 unit. So it will the triangle is uh, right angle triangle POM. So this is X, this is Y, and this is 1. So we know by Pythagoras, we know by trigonometric identity, by cos theta is, this angle is theta, cos theta is x by 1, and sin theta is y by 1, so which is equal to x and y. So we have x is equal to cos theta and y is equal to sine theta. And by Pythagoras theorem and by Pythagoras theorem, we have x square plus y square equal to 1. So cos square theta plus sine square theta is equal to 1, which is a trigonometric identity we have already mentioned earlier. So by taking any point on a circle, we can get trigonometric function for any angle. So by taking any point on a circle, we can get trigonometric ratio for any angle. So for example, we have a circle, and this is Cartesian coordinate. So if you take point P here in second quadrant, which is minus x and y, this is minus x, and this is theta, and this is y. So we get cos theta is equal to minus x and sine theta is equal to positive y. So this tells us that cos theta is negative in second quadrant. So uh, so this is Cartesian coordinate. This is first quadrant. This is second quadrant. This is third quadrant, and this is fourth quadrant. So from above example, point P, where cos theta is negative, cos is equal to minus x, and sine theta is positive. So we can say that cos theta is negative in second quadrant. Cos theta is negative in second quadrant. Now, what are quadrant angles? So all the angles which are integral multiple of pi by 2. All the all the angles which are integral multiple of pi by 2. So pi by 2 is nothing but 90 degree. So before defining quadrant angle, we have to decide the initial side. So before defining the quadrant angle, we have to decide the initial side. So suppose we have Cartesian coordinate like this, and this is a circle of unit radius. So this is a circle. So we have points A, B, C, and D. So this OA is initial side, this this OA is, this is initial side, which have an angle theta is equal to 0 degree. So if we rotate this OA 90 degree anti-clockwise, we get OB 90 degree. Likewise, if we rotate it 180 degree anti-clockwise, we get OC. So now if we take any other point P on a circle, so if we draw a Cartesian coordinate, and we draw a circle. So if we take, first we will mention the initial points. This is A, this is B, and this is C, and this is D. So now if we take point P, any point P, so our initial side is this OP. So this is initial side. So when we measure a quadrant angle, we consider OP as an initial side. So our angle 90 degree when we rotate OP anti-clockwise by pi by 2, we get another quadrant which is equal to, let's say, we get a point Q. And likewise, if we rotate OQ by 90 degree anti-clockwise, we get point R. So this is, so these are the new points P, Q, R, S when we take OP as an initial side. So P, Q, R, S are the quadrant angles when OP is the initial side. So from here, when OA is initial side, then A, B, C, D are quadrant angles. But when OP is initial side, we get different quadrant angles. We get P, Q, R, S initial side. Now we have, so this was about quadrant angle. Now we have, for what values of theta, sine and cosine function do not change. For what value of theta, value of sine and cosine function do not change. So if we take if we take our initial figure with points A, B, C, D, So this is a Cartesian coordinate, and this is a circle of radius 1 unit. So we have initial points A, B, C, and D, whose coordinates are 1, 0, and B coordinate are 0, 1, C coordinate -1, 0, and D coordinate 0, -1. So with OA as initial side, with OA as initial side, this is initial side, theta is equal to 0 degree. So for OA as initial side, we know x is equal to cos theta and y is equal to sine theta. So now cos, when theta is 0, cos 0 is x coordinate of OA, x coordinate of point A, x coordinate of point A. So cos 0 is 1. Sine 0, when sine is 0, then we have y coordinate of point A, which is equal to 0. So this is point A 1, 0 at theta is equal to 0 degree. Now we have second quadrant angle pi by 2, which is at angle P cos pi by 2, which is equal to x coordinate of point B, x coordinate of point B, which is equal to 0. And we have sine pi by 2 is equal to y coordinate of point B, y coordinate of point B is equal to 1. So this is point B is equal to 0, 1 at theta is equal to pi by 2 or 90 degree. Next we have cos pi. Cos pi, cos we can say pi is equal to 180 degree. This pi is 180 degree. So cos 180 is x coordinate of point C, which is equal to -1. And we have sine pi is equal to y coordinate of point C, which is equal to 0. So this is point C, which is -1, 0 at theta is equal to 180 degree or theta is equal to pi. Next we have cos 3 pi by 2. Cos 3 pi by 2, or we can call it 270 degree, is equal to x coordinate of point D, which is equal to 0. We have sine 3 pi by 2, sine 270 is equal to y coordinate of point D, y coordinate of point D, which is equal to -1. So this is point D, which is equal to 0, -1, and we at theta is equal to 270 degree or 3 pi by 2. So last we have cos 2 pi. So 2 pi is the angle of complete revolution. So we have now completed our revolution. We have last quadrant angle cos 2 pi, which is x coordinate of point A is equal to 1, and sine 2 pi is equal to y coordinate of point A, which is equal to 0. So this is point A 1 comma 0 at theta is equal to 2 pi. So from this we can see that after one complete revolution, value of cos theta and sin theta do not change. So from this uh, from this from this we can see that after one complete revolution, value of cos theta and sin theta do not change. So mathematically we can say if theta increase or decrease by any integral multiple of 2 pi, by any integral multiple of 2 pi, the value of sin theta and cos function do not change. The value of sine and cosine do not change. So mathematically we can write sine theta plus 2 n pi is equal to sine theta, and cos theta plus 2 n pi is equal to cos theta, where n belongs to integer. So this is integer. So from here we get the value of theta, after which sine and cosine do not change. Next we have, at what value of theta sine function and cosine function is 0. For what value of angle sine theta and cos theta is 0. So we know sine theta is 0, which is at theta is equal to 0 and theta is equal to pi. We can call it plus minus pi, or we can call it plus minus 2 pi. So like this. So that is theta is an integral multiple of pi. Therefore, theta is integral multiple of pi. So sine theta is 0. So here sine at 180 degrees sine theta is 0 and sine 0 sine is the function is 0. So we can say that at theta when theta is integral multiple of pi, sine theta is 0. We can also see from the figure, if we draw a figure, this is a circle and this is point A whose coordinates are 1 comma 0, and point C whose coordinates are minus 1 comma 0. So at this is theta is 0 degree and point C is theta is equal to 180 degree or equal to pi. So at theta is 0, we have y is 0, which is equal to sine theta. At theta is equal to 180 degree, we have y equal to 0, where y is sine theta. So if sine theta is 0, then theta is equal to n pi, where n belongs to integer. Similarly, we can also find value of theta at which the cosine function is 0. Similarly, from diagram, we can see point B and point D. So its coordinates are 1. So at theta is equal to pi by 2, that is point B, where A is initial site. This is initial site. So if we rotate this anti-clockwise, we get point B. So at theta is equal to pi by 2, we get cos theta is 0. Similarly, if at point D, theta is 270 degree or 3 pi by 2, we get cos theta is 0 because x is 0. So because D point has x coordinate equal to 0, where x is cos theta. So we can say cos theta is 0 if theta is equal to plus minus pi by 2, comma plus minus 3 pi by 2, dash dash dash. So cos theta is equal to 0 if theta is equal to 2n plus 1, odd multiple of pi by 2, where belongs to integer. This is integer. So now we can define other trigonometric function in terms of sine and cosine function. We can now define other trigonometric function in terms of sine and cosine function. So we have cosec theta and sine theta. So from the concept of functions, this is a rational function where f of x upon g of x and g of x is not equal to 0. So here g of theta is sine theta and sine theta should not be equal to 0. So therefore cosec theta is 1 by sine theta. So where theta is not equal to n pi, because at theta equal to n pi sine theta is equal to 0. Similarly, sec theta is equal to 1 by cos theta. So we can say theta is not equal to 2n plus 1 pi by 2. Because at theta equal to 2n plus 1 pi by 2, cos theta is 0. So we have to make cos theta not equal to 0 to define sec theta. Now we have tan theta. So sine theta on cos theta. So same for cos theta not equal to 0. Theta should not be equal to 2n plus 1 pi by 2. for cos theta by sine theta, where sine theta is not equal to 0. Therefore, theta is not equal to n pi. So next we have what are the sign of trigonometric function in different quadrant. What are the what are the trigonometric sign of trigonometric function in different quadrant? So we have so this is a quadrant. So this is first quadrant, this is second quadrant, this is third quadrant, and this is fourth quadrant. So if we take point P in first quadrant, we get cos theta is equal to x and sine theta is equal to y. This is first quadrant. And if we take P in second quadrant, we get cos theta is equal to minus x and sine theta is equal to positive y. Similarly, for other quadrant, P third quadrant, point P in third quadrant, we get cos theta is minus x and sine theta minus y. This is third quadrant. Now in fourth quadrant, we have cos theta is positive x and sine theta is equal to minus y. So we can show it in Cartesian coordinate system. So so if we have point, this is first quadrant. So if we have point P here, x comma y. So this is a positive x-axis and this is positive y-axis. This is negative x-axis. This is negative y. So if we construct a triangle and this is, so we get this is x, this is positive x, and this is positive y. So we get cos theta is positive and sine theta is positive in first quadrant. Now if we take point in second quadrant, P, so this is negative axis, so we get negative x, and this is positive y, positive y. So sine theta is positive and cos theta is negative. So now if we take point P here, we get this triangle. So cos theta is minus x and this is minus y. So sine theta is negative. Now if we construct a point P in fourth quadrant, we get x is positive and this is negative y. This is negative y. So sine theta is negative. So we can write it as follows. From this we can say, therefore, cos theta is positive in first and fourth quadrant. in first and fourth quadrant, and sine theta is positive in second and third quadrant. Second and third quadrant. Also, cos theta negative in second and third quadrant, and sine theta is negative in first and this was about the sine of trigonometric function in different quadrant. We can also find the sine of other by using trigonometries. So next we have what is the domain and range of trigonometric functions? What is the domain and trigonometric function? So what is and domain? So for every point P x comma y on a unit circle for uh, uh, so for what is the domain and range for every point uh, every point P x comma y on a unit circle. So unit circle is radius 1. So we have x minus 1 and plus 1. So range of x is but x is equal to cos theta. So we can say range of cos theta is minus 1 to plus 1. Similarly, uh, range of y is minus 1 to y 1, but y is equal to sine theta. We can say range of sine theta is minus 1 to plus 1. So we can write it in interval form. Therefore, range of square bracket minus 1 to 1.
Range of
Sine theta is -1 to 1.
domain of
Cos theta and sine theta is real number. So we similarly we can find domain and range of other trigonometric function.
so we
Domain
and
range of other trigonometric function. So we have sine theta, we have domain.
and range.
So domain of sine theta is r and range is -1 to 1. Cos theta, domain is r and range is -1 to 1.
Tan theta
Domain is r,
2n plus 1
I by 2 and range is real number. Cosec theta, r real number minus n pi and range is real number. Sec theta, domain is r minus
plus 1
and range
theta
or cosec theta less than -1. Last, cot theta. So domain is r minus n pi and range is real number. That is r. So this is
range of all the trigonometric. Now next we have
next we have how to remember in which quadrant trigonometric function is positive. How to remember
in
quadrant in which quadrant trigonometric function is positive.
so this is a quadrant. Uh, this is a Cartesian coordinate system. So we have this is So this is first quadrant, this is second quadrant, this is third quadrant, and this is fourth quadrant. So we can remember like this. Suppose we have a quadrant like this, and we write like this: add sugar to coffee. So here A means for all, and S means for sine, and T means for tan, and C means for cosine. So this means that in so this suppose we have this quadrant, and so in this, so add sugar to coffee. So in first quadrant all trigonometric functions are positive, and in second quadrant all so in first quadrant all trigonometric functions are positive. In second quadrant only sine function is positive, sine is positive. In third quadrant only tan is positive, and in fourth quadrant only cosine is positive. Next we have graph of trigonometric functions. Graph of trigonometric functions. So we know uh, we know cosine and sine have a period of 2 pi, have a period of 2 pi, that is value of sine and cosine repeats after an interval of 2 pi. Sine and cosine repeats after a interval of 2 pi. So likewise we can find the period for tan theta. So we can find period of tan theta. So tan tan 0 is sine 0 upon cos 0, which is equal to 0. So here is the coordinate system. Again we plot A, B, C and D, and where coordinates are 1, 0 and 0, 1 and -1, 0 and 0, -1. So we have this OA is initial side, initial side means theta is 0. So tan 0 we have 0, and tan pi by 2 means sine pi by 2 upon cos pi by 2 is plus infinity. This is first quadrant, this is second quadrant. Now we have tan pi is equal to sine pi upon cos pi is equal to 0. Next we have tan 3 pi by 2 is equal to sine pi and sine 3 pi by 2 and cos 3 pi by 2, so which is equal to minus infinite. So next we have last 2 pi, tan 2 pi, so sine 2 pi cos 2 pi is equal to 0. So from this tan theta value repeats after an interval of 180 degree. Repeat after an interval of 180 degree, because tan 0 is 0 and tan pi is 0. Also tan pi by 2 is infinity and tan 3 pi by 2 is infinity. So here is an interval of pi and here is also interval of pi. Again we have tan 2 pi is 0, tan 3 pi is 0. So likewise we have so we can say that period of tan theta is pi. So hence we can say the period of tan theta is pi. So now we have a period of sine, cosine and tan. Therefore we can plot the graph of this function, of these functions. No, here is a note. The period of cosec and sec theta and cot theta are same as their parent function. That is, if sine theta period is 2 pi, then cosec theta period is 2 pi. Similarly, cos theta period is 2 pi, then sec theta period is 2 pi, and for tan theta period is pi, therefore cot theta period is pi. So now let's plot the graph of sine theta. So sine theta, so let's plot the graph of sine theta. So first we will plot the Cartesian system. So this is a Cartesian system. Next we have so this is y-axis, this is x-axis. So first mark the point 1 and minus 1. So this is 0 comma 1 and this is 0 comma minus 1. So draw a horizontal line through these points parallel to x-axis. Similar same line through 0 comma 1 to represent the range of sine function. Next we mark the angles. This is 0 angle, 0. Then we have pi by 2. Then we have 3 pi by 2, pi, then 3 pi by 2, and we have final 2 pi. Now draw vertical lines through pi by 2, pi, and 3 pi by 2, and pi by 2, 2 pi, 2 pi. So next we will draw a circle. So we have drawn a circle. Again we mark points A, then B, and C, and D. So we will join B and D. So we have point A 1 comma 0, and B 0 comma 1, and C minus 1 comma 0, and D 0 comma minus 1. So when sine theta when theta is 0, sine theta is 0. So we have this point at theta equal to 0, and when theta is equal to pi by 2, sine theta is equal to 1. So when point moves from A to B, then sine theta value increases from 0 to 1. Then at theta equal to pi, sine theta is equal to 0. So from B, sine theta value decreases from 1 to 0. So graph will look like this.
This is point B, and this is point C. Hmm. Again, at theta is equal to 270 degree, sine theta is minus 1. So it will it, from point C will move to point D, and the value of sine theta decreases from minus 1 to from 0 to minus 1, from 0 to minus 1. So this is point D, and then again at theta is equal to 2 pi, sine theta is 0. So again value of sine theta increases from minus 1 to 0. So this is a plot of sine theta.
So next we have graph of cos theta. So again we plot Cartesian system. So same uh, place point plot point 0 comma 1 and 0 comma -1 as the range. Draw horizontal line parallel to x-axis. So this is x-axis, this is y-axis. Draw horizontal line through 0 comma 1, through 0 comma 1. Now draw a circle with points A, B, C and D. Uh, now plot the points pi by 2, pi, 3 pi by 2 and 2 pi. So we have so at point A 1 comma 0, that is this is point A. At A theta is 0, so cos 0 is 1. So this is point A, this is not point A, so this is point A. From A to B, value of cos decreases from 1 to 0. So this is the plot. Then from at theta is equal to pi, cos theta is -1. So from B to C, value of cos theta increases from 0 to -1. This is point 0. Then the value goes from B to C. Then again at x equal to 3 pi by 2, theta is equal to 3 pi by 2, cos 3 pi by 2 is 0. Again value from C to D. Value of cos theta increases from -1 to 0. So this is point D, and at theta is equal to 2 pi, cos theta is equal to 1. So value of D increases from 0 to 1. So this is point A. So this is a plot of cos theta. So next we will draw the graph of y equal to tan theta. So we will first plot the shape, and then we will mark the points. This is y-axis and this is x-axis. So this is, so we have pi by 2 and we have pi. So we will plot the graph of tan theta up to theta equal to pi, because period of tan theta is equal to pi. Now draw vertical lines through pi by 2. Again draw another vertical line through theta equal to pi. Now draw a circle. Suppose this is a circle.
Now draw a horizontal line. So this is point B, this is point A, this is point C, and this is point D. So again draw a horizontal line through D. So now we have at since since we have OA is initial side, OA is initial side. So therefore at A theta is 0. Therefore tan theta at theta equal to 0 is 0. So at A theta is 0. At B tan pi by 2 is infinite. So at pi by 2 the graph will look like this. So it will increase like this. It will not touch the line, vertical line. It will goes up to infinite. Then again at theta equal to pi, tan theta is 0. So from here it will goes like this. So it will go so this is a graph of tan theta. So this is minus infinity. So this is point B, A to B, and this is from this is a point B. This is from B to C. Next we have graph of cot theta. Graph of cot theta. So again we plot a Cartesian system. So draw a circle. Draw a vertical line. Again draw a vertical line. So this is y-axis and this is x-axis, and the period of cot theta is pi. So we will plot up to pi only. So this is pi by 2 and this is pi. So this is 0, or we can call it A, and this is point A, this is point B, this is point C, this is point D. So from A to B, first draw the vertical lines through pi by 2 and pi. So at point A, at theta equal to 0, cot theta is infinity. So this is not point A. So point A is this. So at this point it is infinity. So from point A to B, cot theta decreases to 0. From B to C, it increases to infinite. So this is infinite. So this is a plot of cot theta. So this is A point, this is B point, and this is C point. Now we have y equal to plot of y equal to sec theta. Again draw this Cartesian product, Cartesian system.
Draw a vertical line, draw a horizontal line. This is x-axis, this is y-axis, and this is point A, this is point B, this is point C, and this is point D. So at theta equal to 0 degree, that is at point A, sec theta is 1. So this is 1, this is point A, at theta equal to pi by 2, sec theta is infinite, sec theta is infinite. So at pi by 2 and pi, 3 pi by 2 and 2 pi. First draw the vertical lines through all the angles, pi by 2 pi and 3 pi by 2. So this is like this. So at pi by 2 infinite, so the value of sec theta increases from A to B up to infinite. So this is point B. Now at point C, theta is pi, therefore sec theta is -1. So from infinite, this is point B. So from infinite, this point C, B increases to C. This is point 0 comma -1. Then at point D, at point T, this is point C. At point D, sec theta is equal to infinite. So again from point C to point D, it will increase to infinite. Now at point last at point A, theta is 2 pi. So sec theta is 1. So again from infinite from point D, this is point D, sec theta decreases from infinite to 1. So this is again A. So this is infinity. So this is a plot of sec theta. Now we have a plot of cosec theta, y equal to cosec theta. Draw horizontal line through the circle. Plot point A, point B, point C, and point D. Again we know that at A theta is 0, at B theta is 90 degree, at C theta is 180 degree, and at D 270 degree, and again at A 360 degree. So this is first plot pi by 2, then pi, then 3 pi by 2, then 2 pi. Draw vertical lines to pi by 2, through pi, so at A, cosec theta is infinite. At B, cosec theta is 1. So point A, this is 0 comma 1, and this is 0 comma minus 1. So at A the value is infinite. So this is point A. From point A to B, value decreases to 1. At point C, cosec theta is infinite. So again from B to C, value of cosec theta increases to infinite. This is infinite. This is point C. At point D, theta is 270. Cosec theta is minus 1. So from point C, this is point C. So it will decrease from infinite to minus 1. This is minus 1. At point A, cosec theta, cosec 2 pi is 0. Cosec 2 is infinite. So again from D to A, the value increases to infinite. So this is a plot of cosec theta. That is 1 by sine theta. Now we have a problem. Let's say, for example, cos theta is equal to minus 3 pi by 5, 3 by 5, which is in third quadrant. Cos 3 by 5 in third quadrant. Find the other trigonometric ratios. Metric functions. So from this diagram, add sugar to coffee. So this is first quadrant, this is second quadrant, this is third quadrant, and this is fourth quadrant. So cos theta is minus 3 by 5, which is in third quadrant, so it is negative. So sine theta will be 4 by 5. In third quadrant it will be negative. Tan theta will be 4 by 3. So tan theta is positive in third quadrant, so it is positive. So these are the other trigonometric functions. Likewise, sec theta is minus 5 by 3, and cosec theta is minus 5 by 4, and cot theta is 3 by 4. So we have to remember this chart, where in first quadrant all trigonometric functions are positive, and in second quadrant only sine angle is positive, and in third quadrant only tan theta is positive, and in fourth quadrant a cosine function is positive. So in the above problem it is mentioned that cos theta is minus 3 by 5, which is in third quadrant. So cos theta will be negative and sine theta will be negative. Only tan theta will be positive. Next we have example. Find the value of sine 31 pi by 3. Find the value of sine 31 pi by 3. So we know value of sine theta repeats after 2 pi. Therefore, sine 2n pi plus theta is equal to sine theta. Therefore, 2n pi plus theta is equal to 31 pi by 3. So let's say n equal to 5. So 20. So it will be 10 pi plus theta is equal to 31 pi by 3. So theta will be pi by 3. So sine 31 pi by 3 will be equal to sine 10 pi plus pi by 3 is equal to sine pi by 3, which is equal to sine 60 is equal to root 3 by 2. So next we have uh, some trigonometric functions. Uh, some trigonometric functions of sum and difference of two angles. So trigono trigonometric functions of sum and difference of two angles. So first is sine minus x is equal to minus sine x, which is sine minus x. So this is initial side, this is terminal side. So minus x will be, it is in fourth quadrant, and in fourth quadrant sine is less than 0. So therefore minus sine. Second we have cos of minus x. So again in fourth quadrant cos x is greater than 0. So therefore positive cos x. Second we have cos x plus y is equal to cos x cos y minus sine x sine y. So suppose we have a circle with the coordinate system. This is a coordinate system. So let's say at angle x we have point cos x sin x. This is point, we can call it A, and at point B, which is at angle minus y, where cos minus y and sine minus y. So join AB. Now find the distance between AB, which is given by distance formula. So we will learn this distance formula in the later chapter, straight lines. So formula is given by x2 minus x1 a whole square plus y2 minus y1 whole square. So if this is a line A and B, so here coordinates are cos x and sin x, and here coordinates are minus y and sine minus y. So distance AB will be cos minus y minus cos x whole square plus sine minus y minus sine x whole square. So this is first equation. Now again we draw a circle. So we have this line at angle x plus y, and we have this initial OD, and this is point C. So join CD. So D point is 1 comma 0, and this coordinate point C coordinates are cos x plus y and sine x plus y. Actually, so again distance between CD will be 1 minus cos x plus y whole square plus sine x plus y whole square. So this is equation 1. Equation 2. So from 1 and 2 we get cos x plus y is equal to cos x cos y minus sin x sin y. So this is the identity we obtain. So we can say that cos x plus y is equal to cos x cos y minus sin x sin y. So there are other identities as well. Like we have secant cos x minus y is equal to cos x cos y plus sin x sin y. Third, a cos pi by 2 minus x is equal to sin x. Sin pi by 2 minus x is equal to cos x. Sin x plus y is equal to sin x cos y plus cos x sin y. Next we have sin x minus y is equal to sin x cos y minus cos x sin y. Next we have cos pi by 2 plus x is equal to minus sin x, and cos pi minus x is equal to minus cos x. Next we have sin pi by 2 plus x is equal to
cos x, and sine pi minus x is equal to sin x. So whenever we have any trigonometric function with pi by 2, with pi by 2, for example sine pi by 2 plus theta. So function, whenever there is pi by 2, function will change. That is sine pi by 2 plus plus theta is equal to cos theta. So this brackets are, we will decide the sign later words. First we will define what will happen if there is a angle pi by 2 in the trigonometric function. Next we have with angle pi. So with this is with pi by 2 and this is with pi, that is sine pi plus theta is equal to sine theta. So whenever there is a pi, the function will not change. Function will not change. So now let's decide the sign. So sine is whenever so we have pi by 2 plus theta. So we will go from initial side to terminal side. First we will count pi by 2. This is pi by 2 plus theta. So this is second quadrant. So in second quadrant sign is positive. Therefore uh, there will be a positive sign. Next we have sine pi by theta, pi plus theta. So we will go 180 degree counterclockwise, and then we will measure angle theta. So this is third quadrant. In this quadrant sign is negative, so here negative sign will come. So likewise we can change find the sign of the trigonometric function. Next we have, for example, a sine pi by 2 plus theta. So again sine and sine pi by 2 plus the pi by 2 means function will change cos theta, and plus pi by 2 plus theta in second quadrant. In second quadrant sign is positive, so positive sign will come. If we have tan pi by 2 minus theta, so there is a pi by 2, so function will change cot theta, and pi by 2 minus theta, so theta will lie in first quadrant. In first quadrant all are positive, so this. If we have tan pi by 2 plus theta, so therefore we have function will change pi by 2 cot theta, and pi by 2 plus theta, second quadrant. So in second quadrant tan is negative, so negative sign will come. So we have tan pi minus theta, so there is a pi, function will not change tan theta, and pi minus theta means second quadrant. Second quadrant means negative. Tan pi plus theta, function will not change because there is a pi, so tan theta, and in pi plus theta, This is third quadrant, so there will be a positive sign because tan theta is positive in third quadrant. So there are some important results. There are some important results. So we have first cos x plus y is equal to cos x cos y minus sin x sin y. Sin x plus y is equal to sin x cos y plus cos x sin y. Third, we have tan x plus y is equal to tan x plus tan y 1 minus tan x tan y. So now we have a half angle formulas. So cos x plus cos y is equal to 2 cos x plus y by 2 and cos x minus y by 2. Cos x minus cos y is equal to minus 2 sin x plus y by 2 sin x minus y by 2. We have sin x plus sin y is equal to 2 sin x plus y upon 2 cos x minus y by 2. And last, sin x minus sin y, so cos x plus y by 2 and sin x minus y by 2. So we have for example sine 15 degree, so we can write it as sine 45 minus 30. So according to, we know sin x plus y is equal to sin x cos y plus cos x sin y. So put x equal to 45 degree and y is equal to minus 30 degree. So sin 45 plus minus 30 equal to sin 45 and cos minus 30 plus cos 45 sin minus 30. So we know sin 45 is sin 45 1 by root 2 and cos of minus 30 plus we know cos 45 1 by root 2 and sine of minus 30. Again we plot the Cartesian system and we know in first quadrant all trigonometric functions are positive, in second only sine is positive, in third tan is positive, and in fourth cosine is positive. So it is saying cos of minus theta minus 30. So minus 30 will be plotted like this, minus 30. So this is fourth quadrant. In fourth quadrant cos is positive, cos is positive. So we will have 1 by root 2 into cos of 30 plus 1 by root 2. So in fourth quadrant sine is negative. So we have minus sine 30.
cos theta is root 3 by 2 plus 1 by root 2 minus 1 by 2, because sin theta is 1 by 2. So root 3 2 root 2 minus 1 by 2 root 2. So we have root 3 minus 1 upon 2 root 2. So sine 15 degree is this. Please remember, this is very important. In first quadrant all is positive, in second quadrant sine is positive, in third quadrant tan is positive, and in fourth quadrant cosine is positive. And whenever there is angle pi by 2 in trigonometric function, the function will change, and whenever there is pi or 2 pi, function will not change. Next we have what is the principal function? What is the principal solution? What is principal solution? So solution of trigonometric function for which for which the value of function lies between 0 and 2 pi. The solution of trigonometric function, trigonometric equation for which theta lies between 0 and 2 pi. And what is the general solution? What is a general solution? So general solution is the expression involving integer n, which gives all solutions of a trigonometric equation. For example, tan theta is equal to minus 1 by root 3. So we need to find value of theta for which tan theta is less than 0. So we need to find value of theta for which tan theta is less than 0, that is negative. So from this Cartesian figure A, in first quadrant all trigonometric functions are positive, in second quadrant sine is positive, in third tan is positive, and in fourth quadrant cosine is positive. So tan theta is negative, tan theta is minus 1 by root 3. So tan theta is negative in second quadrant and fourth quadrant. So we can say tan pi minus theta is equal to minus tan theta. or tan 2 pi minus theta is equal to minus tan theta. So this is second quadrant, this is fourth quadrant. We know tan theta equal to 1 by root 3 implies theta is equal to 30 degree, pi by 6. So we have tan pi minus pi by 6 equal to tan 5 pi by 6, or we can say tan 2 pi minus pi by 6. We have tan 11 pi by 6. So 5 pi by 6 and 11 pi by 6 are the principal solutions. Principal solutions of tan theta is equal to minus 1 by root 3, where 5 pi by 6 comma 11 pi by 6 lies between 0 to 2 pi. So from this we can conclude any trigonometric function can have maximum of two principal solutions, maximum of two principal solutions between 0 and 2 pi, 0 and 2 pi. Next we have general solutions. General solutions. So first is sine x equal to sine y. So for sine x we have general solution is equal to n pi plus minus 1 y. So this is a general solution for sine x, and n belongs to integer. So this is integer. Suppose we have example sine x is equal to minus root 3 by 2. So sine x is negative in third and fourth quadrant, and we know sine x equal to root 3 by 2. Root 3 by 2 is implies x is pi by 3. So in third quadrant x will be pi plus pi by 3, and in fourth quadrant x will be 2 pi minus pi by 3, which is equal to 4 pi by 3, 4 pi by 3, and 5 pi by 3. So our general solution will be x equal to n pi plus minus 1 raised to power n 4 pi by 3, or x equal to n pi plus minus 1 n 5 pi by 3. So there are many solutions to x. Next we have general solution for cos x equal to cos y. So x is equal to 2n pi plus minus y. So this is a general solution for cos x. So if we have cos x is equal to 1 by 2. So cos is positive in first quadrant and fourth quadrant. So this implies x is equal to pi by 3. And in first quadrant, so we have in first quadrant pi by 3 and fourth quadrant 2 pi minus pi by 3. So 5 pi by 3. So we have two principal solutions, pi by 3 and 5 pi by 3. So we have two general solutions, x equal to 2n pi plus minus pi by 3 or x equal to 2n pi plus minus 5 pi by 3. Last is general solution for tan x. General solution for tan x, which is equal to x is equal to n pi plus y. So this is a general solution for tan x. So this was about trigonometric functions and their properties. Thank you.